Graphing composite functions. There's three common composite functions that I'd like you to be able to recognize and graph very quickly. So we're going to draw the composition of functions. I'm asking you to draw a sketch, show a point, determine domain and range. First function, the absolute value of x squared minus 1. So x squared minus 1 is the inside function. We've just drawn a quick sketch of that. It's a parabola, crosses at -1 and 1, has the y-intercept of -1. So that's the inside function. The outside function, the absolute value, is a very common composite function. Here's how we deal with it. Let's look at the points on the graph. Can you see that from here all the way out to the right, all these y values are positive? So starting at this point where x equals 1, y is 0, 1, 2, 3, 4, 5, all positive. When you take the absolute value, they remain exactly where they are. On the other side, from -1 to the left, all those points remain exactly where they are as well. So if we're looking at the graph, from 1 on, the graph remains unchanged. From -1 on, the graph remains unchanged. What happens in the middle? These points are all negative, and when you take the absolute value of them, they become positive. So let's start with this one. This is a y value of -1, so that'll go up to 1. All these y values, instead of being negative, become positive. So that's what happens when you take the absolute value of a function. The positive values remain where they were. The negatives just get flipped upside down so that they're now positive. Positive ones stay where they are. So the absolute value simply takes all your values and makes them positive. Let's look at domain and range. Any restrictions on domain? Is there anything we're not allowed to put in here? Are there any values for x that are not on the graph? The answer should be no. So the domain, x is all the reals. What about the range? When we just look at the red graph, what y values are included? Only positive ones. So the range is going to be y is a member of the reals, but greater than or equal to 0. So when you take the absolute value, you take your original graphs, take all the positives, leave them positive, all the negatives become positive. Domain for this one, x is a member of the reals because there's no restrictions. Range, y greater than or equal to 0, because none of these go below the x-axis. I wonder if there's something common to all absolute value graphs in terms of range. You can think that one over. Let's do another one. Second common composite function type is the square root. So we have the same inside function as before. Now we're going to take the square root. What happens to all the values between 1 and -1? Can you see that all those y values are negative? Are you allowed to take the square root of a negative in the real number system? The answer is no. So when you draw that graph, there will be nothing on your graph between -1 and 1. Nothing will be on that graph. Now, let's go to the right. Square root of a value at 0 remains at 0. Square root of a value whose y value is 1, that will remain at 1. Square root of a value, a y value of 4, square root of 4 is 2, so this point will drop down to 2. So we're a little bit bigger than 2, we'll have a y value of 2. If you went over to 9, it would drop down to 3. Same thing happens on this side. At -1, the y value is 0. When you take the square root, it remains 0. There's some point between -1 and 2 where the y value is 1. That remains at 1 because the square root of 1 is 1. There's some value between -2 and 3 where the y value is 4. That'll drop down to 2 because the square root of 4 is 2. So we get this sort of graph. Better version is this one. And you can see that this y value of 4 is all of a sudden at 2. The y value at 1 remains, the y value at 0 remains. Nothing in here because all those negative y values, you can't take the square root. Square root of 0 is 0, square root of 1 is 1, square root of 4 is 2. Why am I picking values like 0, 1, and 4? Because they're easy to take the square root of. Square root of 5 is right here, but I really don't want to use my calculator to get it. If you're looking for more values that we could use, we could find out when the y value is 9, because that will have a value of 3. And if you really want some more, we could go to a y value of 16, because that would drop down to 4. So this is a fairly common shape for square root graphs. You've taken the square root of a square, and that's why it's looking very much like a straight line. And again, nothing in between. This will have an interesting domain and range. Let's see if we got it right. The domain, what x values are we allowed? Maybe we should zoom back in on that. Looks like we're allowed the reals as long as we're bigger than or equal to 1 and less than or equal to -1. So less than or equal to -1, bigger than or equal to 1. What about your range? What sorts of y values are we getting out? If we only look at the red graph, looks like they're all positive as well. What kind of values come out of a square root? Positives? Might be something going on here. Last one. Whoops. The last one is the reciprocal function, so the 1 over. So again, we start with x squared minus 1, and now we're going to do 1 over this graph. All right, what happens with this graph? What is the y value of the point at x equals 1? It's 0. And when you take 1 over 0, you're undefined. So we're going to get an asymptote, which we would expect. This is a rational graph. Can you find another asymptote in this question? There's one. At -1, the y value is 0. 1 over 0 is undefined. You can calculate the horizontal asymptote from here. Higher power in the bottom, that's an asymptote of 0. So we know that much. Let's go find ourselves some good points, shall we? What are nice values to find 1 over? Y value of 1. 1 over 1 would be 1. So close to 1, there's a y value of 1. 1 over 2 would be a half. So just before 2, there's a half. Can you see what's going to happen with this graph? At 2, the y value is 3. So at 2, we'd have a third. Suspect we'd get one of our usual rational graphs approaching the asymptotes. Okay. Positive on this side should start negative. Let's go for an easy one first. 1 over -1. It'll be a -1. Do you have a guess at what's happening? We're supposed to start negative. We're supposed to go to this point. Do we have any x-intercepts? You can look from here. X-intercepts come from where the numerator of a fraction equals 0, and it can't, so we never cross the x-axis. See if you can guess what the graph would look like. If you're unsure, we'll do some more points. In between here, we have a y value of -1/2. The reciprocal of -1/2 is -2. So that'll be down there. Same thing happens on the other side. There's another y value of -1/2, reciprocal -2. So there's our graph. Approaches the asymptote, started negative on this side. Expectation on the other side, we're negative on this side of the asymptote, should be positive up here. Let's see if that makes sense. We have a y value of 1, 1 over 1. Have a point in there. Y value of 3, 1 over 3. Getting the same graph. Which of course we expected because this is an even graph. If you plug in -x, you get the same thing, so it should be symmetric about the axis. All right, how about domain and range? domain, are there any restrictions on x? Is there anything x is not allowed to equal? Well, yeah, because there's a couple of asymptotes. So x is the reals except for 1 and -1. What about the range? This one's tricky. Are there any y values you're not allowed to have? So if we just look at the red graph, it looks to be always above, so y is always bigger than or equal to 0. Or, how do we describe these ones? Less than or equal to -1. That's different. I don't think we've really seen that before. So greater than or equal to 0, less than or equal to -1. Why are we not getting any values in here? The reason you're not getting any values in here is because we've restricted the domain by saying we're only allowed to have values that go as far as -1. So we didn't put -2 into the function, or -3 or -4. That would have given us values up here. So because we're only using values coming from the original function f of x, we're going to be missing some other y values. All right, so you have 3 standard types of function compositions. We have absolute value, square root, and 1 over. When you have absolute value, all your negatives become positive. When you have square root, numbers get reduced and there's no negatives. And when you have 1 over, you have asymptotes. See if you can get very, very quick at doing this, because then your life will be easier when we go into calculus and graph things quickly. Here's your exercise. Exercise 5. Doesn't look like much, except it goes a to a lot. Have fun.